Welcome to the course Business Analytics and Text Mining Modeling using Python. So, in previous few lectures, we have started our discussion on Python NumPy, and so let's quickly go through what we discussed in the previous lecture, and then we'll pick up from where we stopped in the last one. So, we talked about the numerical Python package, the NumPy package, and how it could be really useful for numeric data processing and quite efficient in comparison to in terms of execution and in terms of memory utilization in comparison to Python built-in capabilities. So, let us quickly go through some of the code that we have discussed before. So, first thing is loading this library module. Then we talked about the ND array, that is n dimensional array object, and we talked about one dimensional array. Let us take for this as an example array with 5 elements. Then how we can create multi-dimensional array. So, you can see that we can use a list of lists, and we can create array 2, which is a 2-dimensional array here, and in this fashion we can access elements. Similarly, another example here we are indicating the data type as well for this array using the d type argument. So, all these aspects we have discussed before. Let us move further. Now, we talked about the array properties in terms of number of dimensions and the shape of array, which also includes the number of dimension and the elements that are there in those dimensions. So, let us quickly go through this. Number of dimension for array is 1, number of dimension for array 2 is 2, and then the shape for array is 5, because this is just a 1-dimensional array. So, just 1-dimensional array with 5 elements, and for array 2 shape is 2 comma 4. So, this is indicating that 2 dimensions, because there are 2 elements for this array, and first one having 2 elements, second one having 4 elements. So, this is about array 2. Now, we also talked about data type and how we can find out that the data type that is there for a particular array. So, in this fashion we can find out for array 2, array 3, right. So, then we can use other array creation function. This part also we have discussed, zeros, and how we can create arrays here. Now, 3-dimensional array using zeros, you can see here. Then this one, you can see this is 4-dimensional array here. So, using zeros function we would be able to create this. Similarly, ones function is there which is very similar to zeros function. So, here also you can see 3-dimensional array, one more 3-dimensional array with the data type also specified. And then we talked about a range function, which is also very similar to range function. This part we discussed. So, after that supported data types. So, most of the data types that we have discussed so far, floating point, complex is also there, integer, boolean. So, all these are supported. So, you can see that. Now, smaller into bigger and converting one data type to another, that part is also how we can use as type function to change the type. So, this part also we have discussed, int to float and all those things, float to int, and the data loss also that goes with it. So, those aspects we have discussed. We talked about string representing numbers and how we can change the data type and all that, string to float as well. Similarly, we talked about the number of bits that are used to store an element and how that can create a problem in terms of when we change one type to another type using as type function. So, those aspects also we discussed in the previous lecture. So, let us move forward. Now, we can also use another arrays objects d type. So, that part also we discussed here. So, you can see here that we can use, you can see in this example, in this 43, that for array force d type is being used to change the data type of array 3. So, all this we have discussed. Now, we stopped at this point in the previous lecture. So, let us pick up from here. So, now there are some shorthand type codes also available in Python environment, especially for this numerical Python, which can also be used to specify these types, data types. So, let us take an example. Let us create a 4 byte long string using empty function. So, this is empty function is another function, another array creation function. So, here we are trying to create this array 8 and np dot empty, and then you can see the second argument we are specifying the u4, the shorthand u type, that is, this is for a string, this is for Unicode of 4 bytes. So, if I run this and if I look at it, so the empty function would actually create an array with 9 elements, and second u4 shorthand we had used to specify the data type there, and you can see in the array, in the output number 45, you can see that each of these numbers, you can see these are randomly given, and the data type you can see uint 32. So, that is comes out to be 4 bytes. So, the same is indicated in u4. So, u4 is essentially representing uint 32. So, this is what we meant by shorthand type code. So, these shorthand type codes can sometimes be really useful in that sense. Now, another aspect that we would like to mention is that if we want to perform batch operations on data, then typically we would require loops, right. So, however, element wise operations can be performed using arrays. So, what we can do where we require loops to perform batch operations, the element wise kind of operations, that can be very easily done and efficiently done using arrays, or of course, of the same size. So, this is something that we refer as vectorization. So, numerical Python, this particular package, these library modules, they really facilitate this vectorization. So, let us take few examples here. So, we will talk about few arithmetic operations, and we will see how these arrays, this particular data structure really facilitates this element wise operations. So, let us take array 2. So, these are the values that are part of array 2. Now, we multiply this array 2 with itself, array 2 multiplied asterisk array 2, then in one go we would be able to get the output, which is also an array here. Now, if we were to perform the same operation without using arrays, then we would require loops. So, probably that will not be that much efficient. Similarly, another example for subtraction, array 2 minus array 2, and you can see that quickly it is performed. Similarly, power operation here, array 2 to the power 0.5. So, essentially these are square root values here. Comparison, if you want to perform, again element wise comparison will happen, and in the output number 50 you can see for each element whether those values were equal or not. We have got a boolean value returned there. So, because we were comparing the same array, then therefore all the values are true. So, you can see these kind of operation, so can be easily performed, and this is what we refer as vectorization. And let us take division. Similarly, if we want to perform these conditional statements, execute conditional statements, you can see array 2 whether it is greater than 1 divided by array 2. So, we will get boolean array here as an output. So, if I run this, you can see output number 52. So, in this fashion we would be able to perform the element wise operations. Now, let us talk about the another aspect of arrays, which is accessing array elements. So, this is also will referred as indexing. So, how we index this particular data structure arrays. So, therefore, the same indexing mechanism is to be used to accessing those array elements. So, this is quite similar to what we have learned in Python list. So, let us take few examples. So, let us take array 2 that we had created. Now, we want to access the array 2 1 within the brackets. If we just specify 1 and let us run this, let us look at the output number 54. If you see, the output is also an array, and you can see if you compare the output number 53 and 54, you can see the first we had a list of list kind of array there, and the first list has been returned there. So, if we specify array to 1, it is actually the the first dimension that is being returned over here. So, this is how. So, first dimension elements happen to be this array element with one array element there. So, that has been returned here, and you can see the 1 is because all these are 0 index. So, you can see 1 is actually 0 is the first element, first list element, and the 1 is second list element. So, you can see that in the output number 54 we have got the second element there. So, that is how we can get this. Now, let us talk about the comma separated list of indices. So, this works like a coordinate system, and for a 2D array we can access an element using a coordinate kind of system. So, first index is like a coordinate along the first dimension, and second index is like a coordinate along the second dimension. So, we use the same array here, array 2, and we specify the our list of indices 1 comma 1. So, 1 will indicate the second dimension, and 1 will indicate the second element in the first dimension, and in comma 1 the second one value will indicate the second element in the second dimension. So, what will happen is if we run this, you can see we got the value 2.2. If you look at the output number 53. So, second dimension is the this list one comprising of 1.1, 2.2, 3.3, 4.4, and the second element in this list has been returned. So, in this fashion, just like a coordinate system, and we would get indices would indicate a particular index along those dimensions, and we would be able to access the elements. Now, let us take another example, array 2 0 1. So, so first dimension first element, second dimension second element. So, that comes out to be 2. So, you can see another example, first dimension first element 0 means first element, and it is coming first. So, first dimension, then next element is for the second dimension, 0 means the first element. So, this is very first element of the array that we had generated, 2D array that we had. So, you can see the value is 1. Similarly, similarly array 3, if we take array 3 here. So, if we take the array example and we just access the third third element here. So, this is we have just one dimension, this is a 1D array ARR is 1D array, as you can see in the output 58. So, this is a 1D array with 5 elements, and when we specify within the brackets just one value 3, this is for the just first dimension, which is the only dimension, and the third value over there, the third index over there, that means fourth value, fourth element in the array. So, that comes out to be 4.3. So, in this fashion you can understand how these values are being accessed. Now, let us talk about the another aspect about arrays, which is slicing. So, slicing is something that we have discussed in list and other data structures as well. So, let us talk about slicing on array. So, is this slightly different from Python built-in list. So, modification, when we perform modification in the slices array, they will reflect in the source array. So, these slices are going to be views and not copies. So, let us take an example, let us take ARR this array, this is a 1D array here. Now, you can see, remember, you can recall the syntax for to perform the slicing. So, array, and within brackets we are indicating 2 colon 4. So, starting from the index number 2 to index number 4, that means element number 3 to element number 5. So, here the last element, the stopping point is not typically included, as you would remember, as we had learned in during list. So, you can see in the output 3 and 4 comma 4.3, these two elements have been written, and 5 has not been written because that is corresponding to the stop point. Similarly, let us take another slicing 2 colon 4 here. So, you can see here another slicing, and let us take another one. In the code line number 62, we had made an assignment. So, all the values from 2, and when we perform this slicing, all the values starting from index 2 to 4, 4 not included, that means 2 and 3, they would be assigned this value 3.5. So, if we look at the output number 63, the values will be 3.5, 3.5. Now, if you look at the original array here in the output 64, you can see these two values, third element and fourth element, they have changed to 3.5. So, the assignment has taken place. So, in one go we can slice an array, and in one go we can assign all the values that are there part of that sliced array. So, in this fashion this assignment can happen. Now, another way to assign, you can see here array 1 we are going to assign 5.5. So, let us look at the output. So, you can see second element has been changed to 5.5. Now, there is another thing where we do not mention any start point or a stop point, just the colon is there, that means the bare slice. So, all the elements would be included in this. So, if I run this bare slice here, you can see array is actually equivalent of the original array ARR in this case. Now, if I perform an assignment operation using bare slice, let us look at the line number 68 array and just column there, and I assign the value 0.5 here, and if I look at the output here, then all the elements of this 1D array, they have been changed to 0.5. Now, let us move forward. Now, next thing is multi-dimensional arrays. So, in this case we need to first understand how we conceptualize multi-dimensional arrays in Python first. So, elements of a higher dimensional array or lower dimensional arrays and not values. So, this we need to understand. So, let us take an example here. So, let us take a 3 cross 3 array. So, essentially it means it is a 2D array. So, array 2D, let us create this np dot array, and you can see this is a list of lists that we are using to create this array, and you can see first list within list is 1 2 3, then 4 5 6 7 8 9. So, if I run this, and you would see this is the array that we have just created. Lower dimension within this 2D array would again be arrays. So, in this case this is 2 dimensional. So, lower dimensional would be 1 dimensional arrays. So, let us look at the shape of this 2 dimensional array here. So, a few points that we can understand here is that number of dimensions in an array is typically number of elements that we have in the in the output tuple of the shape object. So, if I run this array 2D dot shape, and this we have seen before 3 comma 3. So, number of elements here are 2. So, that is the dimension of this array. So, this is first thing. Now, first value in this tuple indicates the number of elements in the first dimension, that is 3, and the second value in the this tuple that we have got from the shape object is indicates the number of elements in the second dimension. Also, we need to understand that these elements of a dimension could be arrays or values. It is not necessary that they are going to be just scalar values, they could be arrays itself. So, just like the output number 71, that is the original array is 2D, but if you look at the first element here in the first dimension, it is an 1D array itself. So, this array 2D, this is 3 cross 3, first dimension having 3 elements which are actually happens to be 1D arrays. Then the second dimension has 3 elements which actually happens to be scalar values. 1 2 3, these are scalar values, but these 1 2 3 as an array 4 5 6 7 8 9, these are 3 arrays that we have. So, therefore, 3 cross 3. Now, if you want to access the lower dimension, so this is how like we did before also array 2D, and if we just specify one value 0. So, we would be just accessing the sub arrays there. So, in this case if I run this, in the output number 73 we got a 1D array 1 2 3. Similarly, array 2D 1 we will get 4 5 6 which is 1D array. Similarly, array 2D 2, this is the third 1D array that we have in this. Now, we can have a look at the number of dimension and shape object as well. So, here you can see dimension of this array 2D brackets 1, this is 1, and similarly if you look at the shape object, you can see just one element there in the shape output, indicating the number of elements in that just one dimension there. Now, if I compare this with the array 2D itself, then you would see that ndim would return the dimension as 2. Now, let us take bigger array in the sense multi-dimensional array, 3-dimensional array. So, let us take a 2 cross 2 cross 3 array here. So, array 3D, and you can see here this is a 3-dimensional array here. So, this is a list of list. So, you can see 3 nested brackets there. That is another way to find out the kind of which the kind of array that we are creating. So, if there is just one bracket no nesting, then 1D. If there are 2 brackets, then 2D. If there are 3 brackets here at the start, you can see the 79, then 3 brackets are there, that is 3D array that we are going to create here. So, that is another way to understand this. So, if I run this, we will have this 3-dimensional array 3D, and you can see in the output. So, if we look at this, then 1 2 3 and 4 5 6, a list comprising of these 2 lists is the first element of the in the first dimension, and a list comprising of these 2 lists 7 8 9 and 10 11 12 is is the second element in the first dimension. Now, in the second dimension we have 2 elements, that is a list comprising of lists. So, these are 1 2 3 and 4 5 6, these are 2 elements in the second dimension. And if we go dig deeper, then there are most nested list there. We have 3 scalar values. So, that is in the third dimension. Then in the third dimension we have 3 elements which are scalar values. In the second dimension we have 2 elements which are list, and in the first dimension we again have 2 elements which are list of lists. So, this is how we need to understand this. Now, again if I try to access the shape object for this particular array 3D dot shape, you can see in the output I have got 2 comma 2 comma 3. So, that is indicating that we have total number of elements 3, that means this is a 3-dimensional array which we clearly understand. And in the first dimension we have 2 elements, in the second dimension we have 2 elements, in the third dimension we have 3 elements. In the third dimension we have 3 elements which are actually scalar values like 1 comma 2 comma 3, and in the second dimension we have 2D array where we have 1 2 3 and 4 5 6, these are 2 1D array. And in the first dimension again we have 2 elements which are list of which are 2D array themselves. So, first element is 1 2 3 4 5 6, second element is 7 8 9 10 11 12. So, clearly the understanding part has to be very clear here, so that we are able to work with all these multi-dimensional array. So, another way to access a multi-dimensional array. So, here you would see array 3D. So, earlier we used to specify list of indices. Now, instead we can specify like this in a recursive fashion, array 3D first bracket 0, then second bracket 1. So, in this fashion also we can specify, that means the first dimension 0th element, that means first element, second dimension index is 1, that means second element. So, that comes out to be 4 5 6. So, if I run this, you can see the output number 82, and you can compare this with the output number 80. So, you can find out how this is working. Again dimensions 3. So, let us move forward. Now, dimensions of array 3D that we have just just talked about. So, this is a 3-dimensional array. So, these are a 2 so these dimensions are 2 cross 3 arrays. So, this is another way to understand this, that a 3-dimensional array in this case array 3D is having 2-dimensional arrays which happens to be 2 cross 3 arrays. So, if I access array 3D in brackets 0, if I run this, this is the first 2-dimensional array which is a 2 cross 3 array. Similarly, array 3D 1, this is the second 2-dimensional array, and this is the second element there in the first dimension of array 3D. So, different ways to understand these multidimensional arrays. So, I am trying to give you different perspectives on how to understand these multidimensional arrays. Now, if we want to create a copy, so we can use the copy method. So, you can see array 3D and in brackets 0. So, this 2D array 2 cross 3 array we can use dot copy method, and we can record it array 3D underscore 0. So, this is one way to copy this array. Now, let us talk about the assignment of values and arrays here. So, let us first start with the value assignment. So, if we perform a operation like this array 3D and in brackets 0, that means the first element in the first dimension, that means the 2D array, first 2D array, and in the right hand side we have 55. So, all the elements in the first element of first dimension, they are going to be assigned this value 55. So, if I run this and if I try to have a look at the array 3D, and you can see that first dimension, first element, which is a list of lists, 55 55 55 first one, then 55 55 55 second list. So, together list of lists. So, this is how this value assignment can make changes in the original array, because as you know, so we are working with the views. So, any changes are going to be reflected in the original array. Now, you can compare this with the array that we had recorded array 3D underscore 0, you can see the values have changed. Now, let us talk about the this assignment using array. So, here you can see that in the left hand side we have array 3D 0 comma 1. So, essentially what we are talking about is 0 indicating that first element in the first dimension, 1 indicating that second element in the second dimension. Once we identified that list, we are in the right hand side, you can see we have 1D array. So, that is going to be replaced with this 1D array having values 66 66 66. So, if I execute this and if I look at the output, you can see the output here, and then reflect it back to if I look at 0 0. So, we had already created 55 55 55. So, you can see here, and we can have a look at here array 3D 0, we can this is another way of assigning this. So, if I run again, you can see we can restore this in this fashion 1 2 3 4 5 6. So, earlier the array 3D 0 1, that assignment that we did, it would have changed the a second list there, second list that we had in the output 88 55 55 55. So, first would remain as 55 55 55 after performing operation number 90, but the second one would be changed to 66 66 66, right. So, in this fashion these assignment of arrays either using arrays or values can actually take place. Now, dimensions of these array 3D 0 and array 3D 1, which are 2 dimensional arrays, are two one dimensional arrays, each having 3 elements. So, if I try to access array 3D 1 comma 0, the output would be this array 7 8 9. So, this happens to be 1 dimensional array. So, this is part of the dimension of array 3D 0. Let us take another example, array 3D 1 comma 1. So, if I take this, you can see we again got 1D array here. Now, next thing is about slicing multidimensional arrays. So, we will discuss this aspect in the next lecture. Let us stop here. Thank you.